mass volume problems. So these are going to be really similar. So I told you grams to moles to grams, right? That's what we chant, grams to moles to moles to grams. In a mass volume problem, one of these will be a volume instead. So if it's starting with mass and going to volume, then this one, they're going to ask you for a volume, such as liters. Grams to moles, you use the molar mass for the conversion factor. Moles to moles, you use the coefficients from the balanced chemical equation. Moles to liters of gas is the 22.4 liters per mole, the molar mass, the molar volume of a gas at STP. So we can use a mass to find a volume of gas at STP. We can also do it the other way around. We can start with a volume of gas at STP and find the mass of something. Here's an example. Dilute hydrochloric acid reacts with 0.928 grams of aluminum metal. What volume of hydrogen gas will be produced at STP? Well, let's take this number, the mass of aluminum, and write it beneath aluminum in the formula. The chemical equation. So 0.928 grams of aluminum. And the question is, what volume of hydrogen gas? It doesn't tell us a particular unit, does it? What would be the easiest unit? Liters. Yeah. The easiest unit for volume of a gas is liters. So this is what we're starting with. We're starting with mass, and we're ending with liters. The mole to mole part is like the centerpiece of the stoichiometry calculation. You always do moles to moles. Some questions, that's all you do, but you always have to do moles to moles. You can't just skip it and go grams to liters. It's not going to work. So we're going to have grams of aluminum to moles of aluminum to moles of hydrogen. And this time, instead of going to grams of hydrogen, we're going to liters of hydrogen. 0.928, the mass given, grams of aluminum. We want to go to moles of aluminum, to moles of hydrogen, to liters of hydrogen. And then sometimes I get tired going left to right, so I go right to left on the bottom. I hope that doesn't bother anybody. Those will cancel out. These will cancel out. And this is grams of aluminum. And those cancel out. Everybody okay with that? I love things where you can learn a pattern and then apply it to a whole bunch of different problems. I think that's good value for brain effort, right? You learn one pattern and you can do all kinds of stuff. Okay, relationship, this one's the easy one, right? Let's do it first. What number's in front of H2 in the equation? 3. So I'm going to put a 3 here. What's in front of Al? 2. So that one's done. Mole to gram, gram to mole. That we use the periodic table. This is an element, so we don't have to do a calculation. We look it up. It's 26.98 grams of aluminum is 1 mole of aluminum. The problem says at STP. Anytime you see at STP, you should think, I might be able to use 22.4 liters per mole. And you might even want to just write it down. 22.4 liters per mole So that's what we're going to use down here. The 22 goes with the liters. 22.4 to 1 mole. And then we calculate 0.928 divided by 26.98 times 3 divided by 2 times 22.4 equals. This should have 3 sig figs, so it's going to be 1.16 liters of hydrogen. Any questions? A comment I often get is, oh, it looked so easy when you did it in class. Well, it is easy for me, because I've been doing this for longer than some of you have been alive, right? So that's kind of depressing. Anyway, it can become easy for you, but it's going to take some practice. And one way to practice is to make use of the videos that I put up. This lecture will be on YouTube, right? So you can go back and start the video and have it show you the problem and try to do it yourself without looking at what we did right now. And then if you get stuck, play the video forward a little bit. Like, oh, that's right, that's where I was supposed to start. And then see if you can finish it out. And we've got a bunch of examples we're doing here, and so you can work through them that way. And after you go through that and feel like you know what you're doing, then go do the homework, okay? It just takes practice. Here's another one. Calculate the volume of hydrogen gas produced at STP from 1.55 grams of sodium metal in water, given the unbalanced equation for the reaction. So we have to balance the equation first. Balancing by inspection, I just look at this, right? I like to start with the first one. It often works out pretty well. Here's a sodium, and there's a sodium. Well, that's all good. Here we've got hydrogen, but over here we have hydrogen in 2 places and hydrogen all by himself. That gets kind of messy, so I'm going to skip him. He looks kind of messy. I'm going to go do the oxygen next. Here's 1 oxygen, and there's 1 oxygen. Okay, now I have to go back to the hydrogens. I got 2 hydrogens here, and I've got 1 plus 2 is 3. Is there a real simple way to get 3 hydrogens over here? You can use fractions, but most students in Chem 101P aren't fond of fractions, right? So we'll just avoid fractions because we can. We've got an even number here, we've got an odd number there. Usually if you just double everything, except the thing that you're working on, it'll kind of take care of itself. So what I'm going to do is I'm going to, well, I didn't really mean to do that. There we go. I'm going to put a 2 in front of this, and a 2 in front of that, and a 2 in front of this. I'm still working on the hydrogen, so I'm going to leave that guy alone for now. 2 sodiums, 2 sodiums. 2 oxygens, 2 oxygens. By doubling all of them, I didn't mess up the work I had already done. But now let's look at what's going on with the hydrogens. I have 4 hydrogens over here. Now I have an even number because this is 2 hydrogens, and 2 plus 2 is 4. It kind of takes care of itself. So if you feel like you're getting in a circle where you've got odds and evens, double everything and try it again. Okay, we balanced the equation. 1.55 grams of sodium. So I'm going to write that right here because that helps me to organize what I'm doing. And then volume of hydrogen gas. So question mark liters at STP 22.4 liters per mole. So what's my path? Grams of sodium to moles of sodium. to moles of hydrogen to liters of hydrogen. Whoops, forgot what I was doing. After you practice it a while and get good at it, you don't actually have to write down the path. But when you first start out, do it. It'll help you. So 1.55 grams of sodium. And if you're one of those people that writes kind of large, these equations get kind of long. They're kind of hard to stick sideways on a piece of paper. If you turn the paper landscape instead of portrait, it gives you a little more space. Moles of H2 to liters of H2. I just had a brilliant idea. I should put lines on my PowerPoint slides, and then maybe my stuff wouldn't veer off all the time. I might try that next semester. Sorry, I get distracted so easily. I call it child-induced attention deficit disorder. My oldest child is 22. I have been interrupted every 5 minutes for over 22 years. I interrupt myself now. Okay, so I put all the units in there. Then numbers. Do the middle one first. Why not do the easy thing first? Get it done. In front of H2, there's no number. It would be a 1. I don't have to write the 1 there if I don't want to, but I will because it bothers some people. 2 moles of sodium. So 2 there. Grams to moles, always molar mass. This time it's an element again, and so it's 22.99. And then liters and moles of a gas at STP, this guy right here, 22.4. 1.55 divided by 22.99 divided by 2 times 22.4 equals 3 sig figs again, 0.755 liters this time. Any questions? It's variations on a theme. I think we can skip that one, huh? You okay with that? Because we've got the whole volume thing coming up. Oh, look, there it is.